has to be determined. 3 comma, and now it doesn't matter if I plug in here or here, right? So this is 45. 45 plus 95 is 140. Now I determine the area right away, which is 3 times 140. So this is this 42, 420? So then the consumer surplus will be the integral from 0 to 3 from 7.5x squared minus 60.5x plus 254 dx minus the area. And the producer surplus will be the area minus the integral from 0 to 3 from the other function, the supply function, plus 95 dx. And I'm fine if we just simply plug this in the calculator now. You already showed me that you know how to determine this in part A and B and the same thing, so I'm fine. At this point, you can even say on the test, see how I did it in parts A and B. Okay? So there is no need here to find the antiderivative one more time and write from 0 to 3. We already did that if we get a problem like this. So, oops. I think I touched it by mistake. Okay, so let's go to the calculator. I'll do the first one. Can anyone calculate the second one for us with math? With I can even I don't know if it allows me to. Ah, look at that. Brilliant. That's how lazy people do it. And they just go and change the limit of integration. Yay! Okay, so I got $137.25. Let me see if I can go back to the previous one. Look at that. I was afraid of typing it again. Brilliant. Brilliant calculator. Thank you. Of course, I have to change this into 420. Okay, 67.5. Done. Great. I don't know if I can do that. Yes, I can. I can show you how to do it with the graphing calculator. My calculator is plugged in. So you just go back with second and entry, second and entry, second and entry. It takes you back to where you want to go. Okay. Are we okay with this? Do we have any questions on the consumer surplus, producer surplus? Anyone? Is anyone following me? Or you let me alone? Talk to myself? I hope not.
Not with this question, but can we do the same process with another question similar?
Absolutely.
So I think like that was 15, maybe doing 16.
If I do 16, then I will not be able to assign anything.
Oh, all right.
But we can choose anything from here, and we can just create a point. We can create a point, and not just, or you know, do you want to use just the equilibrium point?
Doing is the last step. It's finding the consumer surplus and producing surplus, just how that differs from what we did in A and B. It's just different numbers, right?
It's just the area is different, and the limits of integration are different.
Because you're using the equilibrium.
Yeah, I have to determine the equilibrium point. So first in part C, I have to determine the equilibrium point, which is this. And now the limits of integration are from 0 to 3 instead of 0 to 2 jumps as we had before. Mm-hmm. And this area changes because it's this product now. But this product is the same. For the equilibrium point will be always the same because that's how we determine the equilibrium point, by setting these two equal to each other. So these two areas are the same. And now the integral is from 0 to 3. Everything is the same, the rest. Now, when we are not talking about the equilibrium point, then these two do not meet. The two functions do not meet at that point. So that's why their point is different. They are equal only at the equilibrium point.
Yeah, that clarified it. Thank you.
So here I have to have 2 comma d of 2. And for this one, I have to have 2 comma s of 2. And they are not the same. This one is 163 and this one is 125. Because this 2 comma and 2 comma is not the point of equilibrium or the equilibrium point. So this product is different. This product is given by this product, 2 times d of 2, and this number is given by 2 times 125. That's the only difference. That's why I didn't really do anything here. I just plugged them in the calculator to get these numbers. Is that better?
All you were changing, yeah.
But only at the equilibrium point, these two numbers will be the same because they are both 3 times 140. Here, this is 2 times 163. And here, this is 2 times 125.
All right, thank you.
Is that good enough? Are you sure?
Yes. Just figuring out the difference between the numbers that we were using in C, especially with the interval to 0 to 3, and understanding where that came from. That was very helpful.
Yes. So x is given by this. That's why I have 0, 2. But when I determine the equilibrium point, it appears, or we determine that x is 3. So then obviously I have to have 0 to 3. Now, would you like us to look at another problem from here? It's just that the functions are different.
Yeah, maybe something like 13, that didn't look familiar.
Yes, which one? You said?
Number 13?
Yes, let's work on 13. So d of x for 13 is 13 minus x, and s of x is the square root of x plus 17. Perfect. Excellent pick. Okay, so this is 13. And the page was still 454. Good. Okay, so here we're only asked to discuss the equilibrium point. I have to set these two equal to each other. And once I realize that this is what type of equation, then I'll know how to proceed. What is it? What type of equation is it?
Is it radical?
Excellent. Radical equation. Excellent. And how do we deal with a radical equation? What do we normally do to solve?
You square both sides.
Excellent. But please remember, I'm begging you, this is 3 terms. I'm not saying that you would not give me 3 terms, but every time I get only 2 terms, I feel so hopeless. Because this is the first thing we did. I'm not saying you're going to say anything, but many of my students, although we did this, the first thing we did in our class, they still say 169 minus or plus x squared without a middle term. Okay, so 13 squared, 169 minus 2 times the first times the second, 26x plus x squared. It's quadratic now, so everything has to be arranged. I'm moving x, so negative 27x, and I'm also moving 17 and subtract it from 169. So plus 152 equals 0. Always correct my numbers. Okay, I'll plug this in. We're past solving a quadratic equation with punching in and writing it and so on and so forth. I consider that you are way beyond that. So yes, what does it want? Okay, so 1 and negative 27 and 152 I guess it's there, is it? Yes. Okay, 8 and 19. So x equals 8 and x equals 19. A big question mark. Please remember this. We squared both sides. We must check. Okay? We may have one solution, two solutions, or none. But I have to check in the original problem. This is part of the problem. Whenever we square, cube, etc., at both sides, extraneous solutions may pop up. Solutions that are not solutions of the original problem. So when I plug in 8, I have 5 here, and I have 5 here. So this is okay. 13 minus 8 is 5. 8 plus 17 is 25. 25 square root is 5. That is okay. 19? No, because the left-hand side is negative 6, and I don't care about the right-hand side. It's the square root, and it's always positive. So this cannot work. So the only x equals 8. So now I have the equilibrium point as 8, comma, it doesn't matter where you plug it in. Either you plug it in here, it has to be the same. So it's 5. So now I know that the consumer surplus would be the integral from 0 to 8 from dx, 13 minus x dx minus this product from here, 8 times 5. And I'll calculate this. And the producer surplus is this same product, because we are talking about the equilibrium point, minus the integral from 0 to 8 from the other function. And so on and so forth. Now, this, we know it's 13x minus x squared over 2, etc. Let me write those. But and I also want to show this with a graphing yes, that's too easy. I didn't mean that. I meant to show it by hand. So let's determine these two by hand. And you can always check with the graphing calculator. Very good pick, Kristen. Okay, it was a good problem. Okay, so the consumer surplus, so that would be 13x minus x squared over 2 from 0 to 8 and minus 40. And all I want you to show is 13 times 8 minus 64 divided by 2 is 32 and minus 40. And you can calculate this with a calculator, whatever that is. I don't need that. You can do it. But I want to look at the other one. So the producer surplus is 40 minus the integral from 0 to 8 from x plus 17 dx. To be on the safe side, I recommend using a substitution here. And one possibility is let u be x plus 17, du equals dx. No big deal. So this is 40 minus the integral. Careful now. When you plug in 0, you get 17 as the lower limit. When you plug in 8, you get 25 as the upper limit. And this is the square root of u du. Okay, so I'm looking for these steps. And you can check, as I said, with the graphing calculator. Okay, so this is 40 minus. This is, remember, is u to 1/2. And when I integrate that, I have u to 3/2 over 3/2 from 17 to 25. So this is 40 minus 2/3. I plug in 25. The square root of 25 is 5 to the third, 125 minus. I plug in 17. This is ugly. So this is the square root of 17 to the third. I have no idea what that means. Where's my calculator? Oh, let me switch to this, and then we'll check the answer with a graphing calculator. Where am I? What am I doing here? Okay, so I want 40 minus parentheses 2 divided by 3. Open again, 125 minus 17. And the power is 3 over 2, 1.5. You know I love parentheses. Okay, so it's 3.39. 3.39 approximately. And now I'm going to do this just to check my work. Where am I here? And that is, what was 9, I think? No, yes, it was 9. And let me also insert in front of it, because I want the whole thing, 40 minus, okay? And now what was it? The integral from 0 to 8. And of course the x. And the square root. And I have x plus 17. Okay, so when I click enter, I should get 3.39 unless I have an error somewhere. So 3.395 actually, so it's 3.4. Okay, so you can do that. That's helpful, and that's it. Anything else about, do we feel a little bit better now about consumer surplus and producer surplus and the definite integrals? Anyone? Anyone? Amanda, Charlene, Liam, Megan, Zora, anyone?
Yeah, I feel better about them.